Hi, I'm Jason. Let's talk about vulnerability remediation in Puppet Enterprise and how it helps you stay ahead of security risks without drowning in spreadsheets. So, the reality is that in a lot of enterprise organizations, security teams run scans with tools like Nessus or Qualys, and then they export giant spreadsheets full of CVEs, affected systems, and severity scores. And often those spreadsheets are tossed over the wall to IT, who then have to figure out what to patch and where and when. It's a clunky, slow, and honestly pretty frustrating process. And while all that back and forth is happening, vulnerabilities sit unpatched for an average of over 200 days, which is a really long time to leave the door open. Now, that's where vulnerability remediation comes in. It's part of the Puppet Enterprise Advanced tier, and it builds on our advanced patching feature to make the whole process way smoother. It pulls in scan data, matches it to the right nodes, and then figures out exactly which packages need updating. Then you can kick off or schedule remediation jobs. No more guesswork, no more chasing down the details. So it gives your teams a shared view of what needs fixing and a faster path to get from we found a problem to it's handled. Now, this means a lower mean time to remediate and a much stronger security posture. Now I'll hand over to Matt, one of our sales engineering managers, to show you what it looks like in action.
Now this all starts with a new Puppet role known as a transformer node. A transformer node has some services on it that will allow you to contact a security scanning tool and transform that data into something Puppet can read in the Vulnerabilities tab. We can see here an example task. This can run ad hoc or scheduled and bring that information in. Now in our example scenario, we're going to be using the Nessus scanner today. That's going to be our integration that comes out of the box. It's made by Tenable, but there is also a way that a customer can easily design their own transformer scripts that attach to that node to use other types of scanning tools. Now, we're going to walk through our example scenario here. Like I said, we're using the Nessus scanner, and it all really starts with this. This is a Red Hat security advisory, and the security team would see this coming by in a scan, see that they do have some affected systems, and from there they would have to really send this information over in an email and a ticket in a massive spreadsheet of all the vulnerabilities that need to be fixed, along with some prioritization. Again, from here, there's going to be a handoff to the engineering team. Typically, that's going to look something like this. This is an email that just kind of goes over, hey, we found some bad things and we need you to take care of it, please. From that end, the engineer is going to take this action and start figuring out how they can get these vulnerabilities squashed inside their environment. So we're going to go ahead and jump back into Puppet and take a look at our new vulnerability dashboard and how, as an engineer, I can use Puppet Enterprise to solve these issues. Now here's our vulnerability dashboard. I just want to focus on this patching area on the left. Now, since patching was introduced in Puppet Enterprise, this was simply a single overview link that gave some basic reporting and filtering and a task to knock out patches. You still needed to know a lot about Puppet code, Hira. In Puppet Advanced Patching, we've exposed all this in the console, so all of that can be managed without having to know Puppet code. This makes it substantially easier to get started and harness the power of Puppet to control your environment. So let's look at our example scenario again. Now, as the engineer, it's my job to remediate this vulnerability. And I'm going to do that by first filtering for the actual CVE so we can see exactly what we're dealing with. Now, we found it. It's really got a whopper of a score. And we can see here that we have 10 nodes affected. So let's dive in. Now, we're able to see the analysis straight from the scanner. So again, this is all the information security is seeing. We are seeing the same thing. That's what the transformer does. Moves it here so we can look. More importantly, we can see the remediation steps for packages to update. From here, we can simply go and select our nodes. We'll pick everything we got in Linux production. And now we want to go ahead and remediate that vulnerability. Now, this is going to be a fairly familiar interface for anyone that's ever run a Puppet task before. We simply configure our job here with a description. We can select reboot if we'd like to reboot the systems afterwards. And we can also configure extra parameters for the packaging tools here as necessary. From there, it's as simple as moving on to the scheduling page to determine when we want to actually run this patch. From scheduling, we now have the option to run now or later on a schedule. Also, since we're now managing our blackout and maintenance windows for our environment, we can check if we want to override those policies to get this patch. That really depends on who the user is, what the vulnerability is, and how quickly we need to get that remediated. Sometimes this is do it right now. Sometimes it can just be covered during that next patch window, and we'll just set it and forget it. We can come back and just validate that after the patch window's come and gone. From here, we review, and then we go ahead and create the scheduled patch. Now, this is the part of the tour where I pull the completed one out of the oven, but we can see here we have a scheduled patch job, and now if we go into patch jobs, you'll see that it has succeeded. We can simply check here, see how many affected nodes were patched, and then if we scroll down, we can actually see all that task output the same way we would from running any tasks or jobs inside of Puppet. So that's vulnerability remediation in a nutshell. It's a great way to help those security and engineering teams get a much tighter feedback loop as we deal with vulnerabilities, reduce the amount of time it takes to actually fix them in their environments, and not have to pass around a bunch of spreadsheets and do a bunch of finger pointing as we try to get these things done in our day. Thanks for your time.